Hello, I'm Doug Russell, and I'm going to talk to you about machine learning and crop yield prediction. What we're going to cover in this presentation is a paper entitled Coupling Machine Learning and Crop Modeling Improves Crop Yield Prediction in the U.S. Corn Belt. We're going to go over the methods used in the paper, results that were obtained, challenges that were faced, future work considerations, and my own personal reflection on the work of the paper. The paper was published January 15th of 2021, and it aims to determine if a combination of using machine learning techniques and output data from APSIM will return reduced error in crop yield prediction. APSIM is Agricultural Production System Simulator, which is open source software for crop modeling. The figure shows the aggregated annual yields with distribution of residuals around the regression. The data goes from 1984 to 2018. Methods used in the paper were establishing machine learning models without the use of the APSIM models as benchmarks. Those models were then retuned with APSIM inputs as additional features and compared to their respective benchmarks. The comparison metrics were root mean squared error, relative root mean squared error, which is root mean squared error normalized by the mean of the actual values, mean bias error, and the coefficient of determination, r squared. The results of the paper found, overall, the addition of the APSIM features improved the performance on the test set. The model with the greatest impact from the APSIM features was the stacked light GBM ensemble model, which had a 19.8% reduction in the average test relative root mean squared error. The ensemble models in general perform better than the standard models by themselves. This figure shows the benchmark in blue and the hybrid, or those with the APSIM features, in orange. Challenges faced was the lack of availability of genotype data for different plant hybrids over the year range for the data set. This is proprietary for each manufacturer of the seed, and so it's not readily available. Genotype data could be a leading feature, but it's unknown at this point. APSIM models used actual weather data for the years involved in the study. Using this model to predict for future would need to use forecasted weather. That could potentially increase the error in the predictions. Future work. The paper found that water-related features were the most significant and stated that further improvements in the model could be obtained from other sources such as sensors in the fields, real-time Internet of Things type data. My own reflection on this was, before reading the entire paper, I thought precipitation is probably going to be a leading feature. And in fact, precipitation and soil moisture are leading features for accurate crop yield prediction. An example of this is in 2012. It was a drought year, and there was significantly less yield as well as significantly less moisture. This means that moisture and yield are in a positive correlation. Knowing that irrigation is a significant investment for a farmer, we could use this model to show potential return on investment. So a salesperson could talk to a farmer about their current yields and then could show optimal soil conditions with the model and what a predicted yield would be, and from that show a return on investment. I also found it interesting in the paper the number of models that were used and the differences in the models and the ensemble and the stacking and putting the models together with different ways and weighting out their scores in order to make the different predictions. The tuning of the parameters using grid search and how that's computationally expensive were all topics that we discussed throughout this course. This picture here is my stepbrother out in his cornfield back in 2018. References for the paper, as well as the images used in the presentation. Thank you.